so let's talk about the outliers. So outliers is a data value or values that are out of the norm or called extreme values. They are values or value sets values that are far apart from the other data sets. And the question is, how do we know if a data value is an outlier or not? So, how far apart does it have to be when it comes to it? So from naked eye and just guessing, it's not very good. So we have some rules to apply to help us out when it comes to it. So the first way we're going to talk about, to see if a data set is an outlier, is something called the Interquartile Range, or IQR for short. Okay, so this is the 50% range of the data set, and the equation for the IQR is equal to this. It's your Q3 minus your Q1. Okay, so that's the first thing you have to find, the Interquartile Range, or IQR. It is Q3 minus Q1. Okay, now after that, here is how we find outliers. So we need two very special numbers, something called the lower fence and the upper fence. Okay, so the lower fence equation is your Q1 minus 1.5 times the IQR you get, and your upper fence is your Q3 plus 1.5 times the IQR. Okay, now you can kind of think like an algebra. This is kind of like a buffer. So all the numbers between your lower fence and your upper fence are good values. Everything that's outside of them will be considered outliers themselves. And that's what I emphasize on the next page over here. It says if a data value is less than the lower fence or greater than the upper fence, it is considered an outlier. So again, if you think of algebra, you can kind of think of that portion here as any numbers between the lower fence and upper fence are okay. Everything outside of them will be considered outliers themselves, or farther than actual when it comes to it. Okay. So let's put this to practice to help us see each other out. So let's do the question 3 together, and then you guys will do question 4 yourselves. Okay. So question 3 says, given the data set of the number of students in stats classes, such as college, find the quartiles of the data set and construct a box plot. Then interpret what each box plot means. Lastly, find any outliers in the data set. So a lot of information we want to find here, right? So first we want to find the quartiles, right? Q1, Q2, and Q3. So I'll give you guys a quick pause and want you guys try to find the quartiles here. So 3, 2, 1, pause. Okay, so hopefully you guys tried them. So now let's go over that. So again, right, they're not in order. So that's why I need you guys try to use yourselves, put them in order. So not too big of a list, right, when it comes to it. But hopefully you got your quartiles as 16, 25, and 35. Okay. So you can think of it as part A, right? We found the quartiles of the data set. Okay. Next thing we want to do is construct a simple box plot, right? So now you can see what it means by a box plot. So we're going to have a scale at the bottom, and usually you can start and end when your smallest and largest value. So in our case, our largest value should be 37, I believe. Yeah. So 37, and the smallest value we have should be 12. Yeah, 12. Okay, so here's my minimum, here's my maximum, and I'm going to just do my proportional. So it doesn't matter how far you want to go when it comes to your scale. Since it goes to 37, I'll probably go by a couple. So let's say, let's just say this is 10 up to 40 here. So I'll go by 10. So 10. 20, 30, 40, roughly like that. Okay, so 16 is approximately halfway. 25 is roughly here. And then 35 is roughly here. And then we just make a box. Again, it doesn't have to be too fancy, when it comes to it. Just a simple little box plot. Okay. All right, so that's the portion. And the next thing, we want to interpret each quartile. So I'll just do one and you guys can do the rest. So for, let's say 16, right? So let's say 25% of all of the data set is at or below the value of 16 when it comes to it. And the rest are almost identically the same, right, when it comes to it. All right, so now lastly, we want to find any outliers. So that's using the last stuff we just did, right? So the first thing we want to do is find the IQR. So the IQR in this case will be 35 minus 16, which should give you 19. Okay. So next thing we want to find is the lower fence and the upper fence. So remember, our equation for lower fence is your Q1, which is your 16, minus 1.5 times 19, and the upper fence is 35 plus 1.5 times your IQR. Okay, so put this in a calculator and see what we get here, right? So for our lower fence, you should get negative 12.5, and for our upper fence, you get 63.5, I believe. Okay. So here's a question. Do we have any values? So looking back to our data set, so any of these numbers who are less than this or greater than that? And hopefully you say no, right? So there's none. So we have no outliers in this set. Now, however, let's suppose this 37 was 100. So if that was 100, now do we have any outliers? Hopefully you say yes, right? Because 100 is greater than 63.5. So therefore, the value of 100 would be considered an outlier. So we would say the outlier is the value of 100 if that was the case. Okay. So why don't you guys try question 4 all together when it comes to it. So I'll give you a quick pause. So 3, 2, 1, pause, and go for it. All right, so let's see how many car accidents are in Glendora, right, when it comes to it. So first we get our Q1, Q2, and Q3. So hopefully you guys got 8, 16, and 20. Okay. So box plot, you guys can probably do that one pretty quickly. And then I'll just go straight to the outliers. So IQR hopefully is 12, right? 20 minus 8 is 12. So lower fence is going to be 8 minus 1.5 times 12. And upper fence is 20 plus 1.5 times 12. So let's see what we get for our lower fence. Let's get negative 10. And for our upper fence, 38. So do we have any outliers? Hopefully say no, right? There's no numbers in our data set that's less than negative 10 or that is greater than 38. So just like the last one, we have no outliers. Okay. And that's it for these two sections. Pretty straightforward when it comes to it. The whole process is just knowing these equations, being able to manipulate. And one thing I forgot to mention, but it should be common, right? Order operations. You multiply before you subtract, right? So don't just plug in 16 minus 1.5 in the calculator and then times it by 19, right? That's not order operations. So you still have to do some operations even though you're allowed a calculator in the class, right? Comes to it.